I wanted to go over some messier problems from the homework that talk about substitution. I think the choice of u is kind of the harder things for these. So let's spend a little time on that. We're going to start with number 4, which is the integral of e to the 10 over x squared dx. Looks kind of weird, kind of messy. Again, we have a fraction, a function over a function. We're going to need to use substitution to deal with that. We don't have a quotient rule for integration. We usually choose inside functions for u. So here's an inside function. Sometimes we choose denominators, but this is not really going to help us. The derivative of x squared is 2x, and we don't really have any of 2x's lying around. Another thing that you think of on that lines when you're looking for a u is its derivative lying around somewhere? The derivative of this is a little hard to see, but let's just run with it and see what happens. If u is 10 over x, what is du? Well, remember that this is just 10 times x to the negative first power. So with the power rule for derivatives, we get negative 10 x to the negative 2. What does that look like? That's telling us that du is negative 10 over x squared. This is good news, because we have a dx over an x squared. All that we're missing is a negative 10. So let's rewrite this integral a little bit. So let's write this as e to the 10 over x times dx over x squared. Exact same thing, right? Dx, we can think of it as divided by 1. And similarly, this we can think of as divided by 1. So we haven't cheated. We haven't changed anything. And if we have a negative 10 here, then we have our du. But if we multiply by negative 10, we need to divide by negative 10 too. But we can totally do that. So we have negative 1/10. I don't like writing negatives in the bottom. I like writing it in front. The integral of e to the 10 over x, and remember 10 over x was u, right? This was u. We said this was exactly du. And we get something really nice. It started off really messy, but a quick substitution made it look super good. We get negative 1/10. What's the antiderivative of e to the u? Itself, plus a constant. The last step was to put everything in terms of x. We get e to the 10 over x plus c, and you can check your answer by taking the derivative of this. If you took the derivative of this, you should get the original integrand of this. All right, let's also look at number 7, the integral of dx over x ln x. This one's also a little weird because, again, there's no real inside function. The only thing on the inside of anything is x, but this is not a substitution. U being x, there's no functions here. You're just changing the letters. So that can't be it. So really the only other natural option is for u to be ln. How can we know that this is a good substitution? Because the derivative of natural log is 1 over x. And we have a 1 over x right there. So du is the derivative, which is 1 over x. Have that from our 2.5 formulas. And this is great because this is exactly what we have. If we wanted to, right, we could rewrite this. We have 1 divided by the natural log of x times 1 over x times dx. Because if we combine everything, we'll get what we started with. So this right here is u. This right here is du. we just have 1 over u du. Another really nice integral. Although something pretty funny is going to happen here. So look at this. What's the antiderivative of 1 over u? The natural log of absolute value of u from your formulas in 3.3 plus a constant. What was u? Well, u is the natural log of x. So we have the natural log of the absolute value of the natural log of x plus c. Isn't that fun? Wow. What a cool, quirky problem. And you can actually get some really funny problems that I'm probably not going to throw at you, but there's some fun problems out there, let me tell you. All right, let's look at this minuscule definite integral. Hope nobody's watching on like a phone or something. You won't be able to see this. Don't worry, I'll make it bigger. So we have the integral from -2 to 2, 2x over 1 plus x squared dx. Again, we need a substitution here. We have a fraction, a function over a function. We can't simplify because you can only break functions apart if the addition's on top. The addition's on the bottom, there's nothing we can do. So we can't break these fractions apart. We have a quotient. We're going to need a substitution. Again, there's no inside function here. But there is a denominator. Denominators are also often good choices. Because if u is our denominator, what is that? Du. All right, that was not as good of a pun. The derivative is 2x, which is great because we do have a 2x lying around. We always want to choose u in such a way that its derivative is somewhere. So du is 2x dx. Oh, beautiful, perfect. We have that right there. We have our du right there. So this really is the integral of du over u. Let's convert everything into u's. So if x is -2, oh, I didn't actually think about this when I assigned the problem, but it's going to be good. I'm glad I chose this problem. Look what's about to happen. If x is -2, well, u is 5. -2 squared is 4. 1 plus 4 is 5. And if x is +2, what happens? So many funny jokes in these homework problems. I hope you're laughing with me. If x is +2, u is 1 plus 2 squared. It's 5. Oops, sorry, should be writing 5 down here. We're integrating from 5 to 5. We didn't talk about this property. But what is a definite integral? It's the area under the curve. So what's the area? This is 1 over u. This is what 1 over u looks like. What is the area underneath the curve? What's the area of this red line? Lines don't have areas. And you could do this all out. You don't have to stop here. You could do this all out. But you're going to get 0. Right? If you do this all out, you get the natural log of absolute u from 5 to 5. You get the natural log of 5 minus the natural log of 5. You're going to get 0. You can do this out the normal way. You don't need to recognize this. But we can have an opportunity to connect to these concepts. Definite integrals are areas under curves. Well, if we don't have a region, there's no area. Another way to think of it as why it's 0. You could also see that this area is 0 by looking at what the function looks like. We're looking at the area of this original curve from -2 to 2. What does that look like? Well, let's graph the function. From -2 to 2 is the area. Oh, it's the signed area between these two lines. So it's this positive area minus this negative area, or plus this negative area. This area minus this area. It's the same areas. This area is positive, this area is negative. They cancel each other out. And again, you could also check your answer with Desmos from -2 to 2 of this function. Oops. You could still see that it's 0 that way. So funny little problem. Ha ha ha. But good practice for what a U substitution looks like for a definite integral. Hope I love integrals actually. I wish we got to do more integrals in this class. Hope you're happy to. Otherwise, ask questions. You're not alone. It's okay to be tired. It's okay to struggle, but just reach out and good luck. Bye-bye.